So here is the situation where we are today. Even we have made a significant improvement over the years, but we still have a lot of problems. But the situation is that more and more enterprise or users are adopting Hadoop as their mission-critical systems. They use Hadoop to do more and more things, and they, of course, they expose more and more data to put more data on the Hadoop cluster. But in the same time, they expose the data to more and more users. Previously, it's just like a few data scientists in the enterprise, or some engineers to do their prototype. But now, not just those users, but also general users, such like data analysts or business users, are using Hadoop to achieve their enterprise functions. So one of the typical use case is the data warehouse. And we know that data warehouse provides insights into the business, but with the scope of the data that we are experiencing today, traditional data warehouse just doesn't scale. So that's why we naturally take Hadoop as an extension to existing data warehouse to solve the same problem, but in the context of big data. So because of this, and also because of the familiar interface, SQL, right? We become a phenomena because SQL provides it's the things that we are familiar with. Right? We are all coming from the relational world, but we are still are in the relational world. And for big data, it is still the case. Sorry about that. So it looks like I need to turn the slides faster. So, but there are problems too. Right? So one thing is that it's about security. So enterprise, because they put more data, including sensitive data, they want to protect the data. And also, so that's the internal force. There are all external force. That's the government, right? So there are a lot of government regulations that require certain security measures to be taken to guide the data. So we have the laws like HIPAA, PIR, FISMA. On the other hand, the Hadoop, right? It's Hadoop has this security problem. So to a certain extent, this problem has hindered the further adoption of the Hadoop. So if we say Hadoop is very secure, then I would imagine that there would be even more users of Hadoop. So because of this, security has become to the top priority for a lot of components in the Hadoop ecosystem. So nevertheless, we still have this the problems. So the problems including like even though people are around the world working on this improve the security, but Hadoop will still have have the different component, implement the different security mechanisms, and but to make things worse, a different component can access the same data, right? So if you have some certain data, those data can be mounted to a Hive table, or be accessed by a pig script, or by some MR jobs. So, and Hadoop was born out of trust. So at the very beginning, we want to make Hadoop work first, right? Then we try to solve the security problem. So because of this, so there's always a lack of security in all the either framework applications in the whole ecosystem. So it's very similar to the how Windows system operation system become the same path that the Windows system has gone through. So now give you a little bit more information about security concept, especially in the Hadoop world. So security, there are mostly, when we talk about security, there are four components or four aspects of security. So that's authentication, authorization, data protection, and governing, auditing. So authentication, so it's to identify who you are, right? So whenever you access the system wants to know who you are. So whether you are really what you claim you are. In the early stage of Hadoop, right? The mechanism we had was, so we have isolated Hadoop cluster, and only certain users can access this network. So we provide the network layer at the network level, and also we assume that if you have access to the Hadoop cluster, you are trusted. You are a very good citizen. So, and ironically, right? So who you are is actually is determined by the client host. So that basically means your username is defined in your local in your client machine. It's the username of your client machine. So we know. So you would know how secure that is. So Hadoop later on introduced a strong authentication. That's Kerberos. Another Kerberos is strong authentication, but for most enterprise, they already have their authentication system, such as LDAP or Active Directories. So in a lot of cases, in the Hadoop world, they have LDAP or Active Directory actually integrated with the Kerberos, so they work nicely together. So which provide a single point of truth. And of course, once the authentication is in place, people like convenience. They want to single sign on. So I'm not sure how real it is today, but I think that's one of the goals that the community is trying to achieve. So a little bit more information Kerberos. So it provides strong authentication, and it also provides neutral authentication. It's not just the server authenticates the user, but it also allows the user to or client authenticate the service, so that it can protect against like a eavesdropping or replay attacks. And a user or a service has a Kerberos principle. So a principle has a credential. It's usually in terms of, like for a service, it's called KTAB. That's where you store your key in a file. That's your credential. Usually for a user, it's just a password. So the second aspect of authentication, security is authentication. It is used to determine what you can do. So once you authenticate it, but it doesn't mean you can do whatever you want to do, right? So it determines what you can access. So the your means or the existing mechanism that Hadoop provides is the HDFS POSIX-style read-write permission at like 3 levels, like user, group, or word. It's coarse-grained because it's on the file level, file or folder. So of course, other components also provides authorization, such as the MR. It has queues that you can decide who can put jobs on a particular queue. Or HBase, like it has ACLs on the column family level or on the table level. And Kumano even goes further, providing cell level authorization. So impersonation is also sometimes it's very widely used. So when a service has no means to do the authorization, so it say, okay, I cannot determine whether you can do or not, but let me dedicate your request to the underlying system, such as the file system, to see whether you can do something. So the third aspect is about data protection. So in other words, it's called encryption. Encryption is to protect the data. So even the data get compromised or stolen, or so it makes sure that the data is still unusable to unauthorized users. So the encryption is the mechanism, and Hadoop today provides encryption on the data in transit. Right? So data transit means the data when the data is transferring in the network. But we also need data protection for data at rest, which means when the data is actually stored in the storage, such as in a file system. So today Hadoop has no encryption on that, but there is an active project going on, and there are a lot of discussions. So if you are interested, follow that discussion. There are a lot of fun over there because it's a really complex problem to solve. And once you do encrypt, right, you will need to use keys. Then how do you manage this case? How do you rotate the case? Right, so all those things are exciting but are very complicated. So currently, it only relies on the OS level encryption. The last aspect of the security is the governance or auditing. So which is provide proof that whether your data actually get compromised or get protected as expected. So again, in Hadoop world, it's implement component to component. For example, DFS and MapReduce provide some basic auditing log that you can check, and our Apache Hive metadata can record your what queries you run. So it has a basic audit support, and of course, the Apache Woozy also provides your audit trails for your service usage. So now let's formally introduce Sentry. So Sentry is not for everything, but it's only for Hadoop authorization. So that's the second aspect in my previous slide. So it assumes that the user is authenticated, and so right now the current situation is that existing authorization, different components implement a different mechanism. And so because it's so complicated or sometimes very inconvenient, so a lot of times the enterprise just put data unprotected. But that's not a long-term solution. So what the enterprise really need is an authorization component that works across your enterprise for all the components. And it should be ease of use and fine-grained and role-based. So I will talk more about role-based next. So as I said, Sentry provide authorization for many modules, many components like Apache Hive, Search, or Impala, and beyond. So, it has it meets the key requirements for like a role-based access control, such as secure, fine-grained, or role-based authorization, and it has the multi-tenancy support. Yes, it's open source. It has been in the incubator project for over a year, and it has brought Hadoop ecosystem support. So here are the benefits of if you use Sentry. So you can store feel more confident to store your sensitive data in Hadoop, and you can extend your Hadoop data to more users, and you can comply with the necessary government regulations. So here, what Sentry can do for you, it provides fine-grained authorization. So you can do fine-grained means it's not just a file or folder. It's you can provide access control on servers like databases, tables, views, index, connections. So it depends on what application you have. So you can define your resources to protect. So it is role-based, which means that the administrator work on the roles, like the actual functional role that you play in your enterprise, rather than the detail, like the very low-level concepts like read this table, drop that database, things like that. So it's role-based, and it has this multi-tenancy support, which means you can dedicate your certain authorization, your sub-level components to other administrators, so that you can so it can be maintained better, so that we don't burn one guy down. So here is the architecture of the Sentry. So in the middle is a policy engine. That's where the work is actually done. So it evaluates. So whenever there is a request, basically they will give you an answer, say yes or no. But based on what? It's based on the things I will come next. But it basically evaluates these rules. You define a lot of authorization rules. And on the top is we call the binding layer. That's the hookup component provided by Sentry, but you can use to hook up your applications such as Impala, Hive Server 2, or Solar. If you have other applications that you want to use Sentry, then you can of course Sentry can provide you the binding layer, but all you need to do is just use that binding layer and in your application. So on the lower part is where the policy is stored. We call the policy provider. So right now it can start on file or on the database. So Srayva, we're talking more about this part. That's the new. So previously we only have this. So you can store your policy in a local or HDFS file. So here is Sentry in action in the context of a SQL, like a Hive. So, for example, let's say if Hive is using Sentry for authorization. So what happens is if Hive receives a SQL, it validates the grammar and construct a AST or syntax tree or statement tree. So then we will invoke Sentry and check with Sentry, say, okay, this is the order this is the user, this is what the user trying to do, so whether we should allow this procedure or not. So Sentry reply back either yes or no. If everything is good, so it go further and to process the query. So here is the components that get involved in when you define your authorizations and policy. So we have users and a user group membership. That's where so a user and what groups the user belong to, and resources. That's where what the things that you want to protect or file or table. Privilege is an action on resources. Or a role that's basically a list of privileges. So we will talk a little bit more on each. So user, so usually we assume that the user is authenticated, and usually the user identity is actually obtained from the session context. So that's a that give you convenience on both to the system or to the user. So user group membership. So this usually is defined outside the Sentry's policy. Usually you get this from your your user directory, such as LDAP or Active Directory, or sometimes from the HDFS, the file system. So this can also sometimes be available from the user's session context. resources is the data that you want to protect. That could be a file or directory on HDFS, or it could be like a table or view in Hive, or just a general URI. Or so resource can be hierarchical. That's why you can say, okay, I only the super domain only guard this top level, then it allows to sub-level to be managed by separate administrators. So privilege, as I said, is an action or operation associated with the resource. It only exists in a role in the sense that you cannot grant action or privilege to a user or user group, but you only define privilege in a role. So the privilege, the examples like you can whether select on given table or view, or create a table in a database, or you can query on a search connection, or you can delete a file or directory in a file system. So I think there's an example that's like a connection. So this is defining a privilege. Basically, it's on the left side is the resources, and on the right side is the action. So that's what you would say if you use the file-based policy. Roles is a collection of privileges. So a role can have one or many privileges. So it's defined in the Sentry policy, and you can grant a role, not individual privileges to a user group. So here are the examples. On the left side of the equal sign is the role, and on the right side is one or many privileges. So this here is a group or role mapping is where you grant the privilege to users. So you say this user group can have this privilege or this role. So for example, the user belongs to analyst, so analyst can have these privileges. So it's also a one-to-many relationship. So here are some examples. On the left side of the equal sign is the user groups. So it says user groups have these roles. So role evaluation, as we shown in the previous slide on the SQL example. So it go like this. So Sentry will first check, say who is the user. That's the user's identity, what groups the user belongs to. So we get a list of the user groups from the user directory. And what resource the user is trying to access. Is a file or folder or a connection, or just some directory. And how the resource is accessed is either read, write, or query. And then the final check would be, I say, does any of the users groups have a role that grant the user to access the given resources? So if the answer is yes, so that give you a green light, and it allow you to go through. Otherwise, it does stop you right there. So that's how the access control works. All right, so that's pretty much what I have. But the more exciting part is the next. My colleague Srayva will give you the recent development, the things that we just achieved recently, and hopefully you will get some insight from there. So I will come back for Q&A. Thank you.
Hi everyone, my name is Srayva. I'll be talking mostly about the recent developments in the Apache Sentry project. So as my colleague Xuefu mentioned, so a few years back, there were Hadoop clusters in the companies, and there were just like a handful of engineers using Hadoop clusters. So the question of, how do we provide authorization control and security was less priority question to ask. So now, thanks to rapid Hadoop adoption across the companies, now we have hundreds of users trying to use the Hadoop clusters and sharing the data. But we also need to make sure we don't expose all the data to everyone. And Hadoop clusters are no more like a POC clusters. They're in production, hosting sensitive data. So it's even more important to protect the data and have fine-grained access control. So coming back to the latest development, a quick overview of what we had in CDH5 and what we're shipping in the CDH 5.1. So in the old world, Sentry used to work with policy files. So what that meant was you have, as Xuefu mentioned, you have a set of roles and you have a set of privileges assigned to these roles. So you can have either one policy file or you can have a tree of policy files for Hive, Impala, and Search. So that was all working good, but imagine you have thousands of tables in your Hive warehouse, and the policy files really gets very difficult to manage. So one of the things which we worked on was SQL kind, Oracle MySQL kind of interface where you can grant and revoke privileges to users. So that is what the Sentry service is about. So if you look at the picture, so Sentry service is basically a thrift service, which basically talks to a backend DB storage, where you can store all of your privileges. We also have a Sentry service client in Java and Thrift. So the Hive binding basically, the Hive beeline basically provides SQL syntax for grant and revoke. So you can create roles, you can grant the roles to the groups, and you can grant privileges to the role. So all of these privileged data is stored in the backend DB. And let's see how different services interact with the Sentry service. So Hive Server 2 basically talks to a Hive Sentry binding, which lives in Sentry. So it can either talk to the old file-based provider, or it can talk to the database provider. So database provider basically uses the Sentry service client, and it talks to the Sentry service for all its requests. And coming to the Impala world, Impala is a SQL engine which is near interactive. So we really have to serve the privilege request fast. So how Impala interacts with Sentry is it has a service called Impala Catalog Server, which basically pulls the privilege data and caches it on each node. So that Impala-D has a local copy of the privileges which it can look up based on. So this is the flow for the Impala. Impala uses a cache-based policy provider. By the way, feel free to stop me if you have any questions in between. And another big feature we've worked on recently is Hive Meta Store security. So what that means is, so there are multiple ways of accessing the Hive Meta Store. The most widely used popular ways are through Hive or Impala. So both Hive and Impala provide a SQL interface for the users. So you can just do a select star or a table, which is created out of semi-structured data. So and there are not just Hive and Impalas like SQL engines like Hive and Impala. You can also write pig scripts which work on the Hive Metastore data. So pig scripts essentially read the data and converts the script into a MapReduce job for you. So you don't have to write low-level MapReduce programs. And there's also, there's a H catalog, something called H catalog, which basically talks to Hive metastore to get all the information of the metadata stored in Hive warehouse. So it knows, where exactly each table is actually present on the HDFS, and it knows other information like what are the columns this database has, what are the tables this database has, columns, the schema, and what are the file formats you're using, and so on. So it basically contains all the metadata about your tables and databases. So big users typically, big users who want to use Hive warehouse data typically use HCAT to get all that information. Even MR users can use HCatalog to get all the metadata information. And there's also with HCAT, it's basically, we can write REST-based apps using web HCAT to create and do all metadata operations using web HCAT. So there was, so as you can see, there are lots of entry points to Hive metastore apart from SQL engines. So the new feature here is earlier the Hive metastore was access controlled only through Hive, Impala, and Search. Now the Hive metastore, there's a plugin, Sentry plugin in Hive metastore, which would also provide you access control in Hive metastore itself. What that means is your PIG users and MR users can also will also go through Sentry. One thing to note is the Sentry plugin in Hive metastore is not as robust as the Sentry plugins in Hive Server 2 and Impala, for example. It right now protects only the read path for the metadata. So that is the thing. And one other small thing to note is, as you may know, Hive Server 2, for example, is a service, right? So all of the interactions, all of the SQL queries which you give against Hive Server 2 are performed as a service user rather than in the user space, right? So it's very easy to manage that. So what we recommend is Hive Server 2 owns all of the warehouse data. So what we recommend is 770 on the warehouse data, where only Hive and Impala can read write. So naturally, Hive HDFS data is restricted from the rest of the world. So in the case of PIG, what happens is all the queries, all the scripts are performed as a user. So I'm Srayva, and if I'm writing a PIG script, the Hive metastore data is all accessed as Srayva rather than a super user. In that case, the HDFS permissions gets tricky. So right now, Sentry doesn't handle HDFS permissions when you're going through PIG and MapReduce route. Although if you're going through a Hive or Impala route, all the operations are performed as the super user, so you're taken care of with the HDFS permissions. So essentially this feature would allow even the PIG users and MR users to use Sentry. So this is about the new features. I'm going to show you a quick demo, very quick demo. So this is a Cloudera managed cluster. And also some of the improvements in the recent past is, how do we configure Sentry? How do we make it easy to configure and get started? So right now it's very, very simple. You basically have to, start a Sentry service. And most of the configurations are, pre-configured in Cloudera Manager. So once you have your Sentry service up and running, all you have to do is you basically have to say, okay, my Hive depends on this Sentry service. That is all. So once you say your Hive is depending on Sentry service, all the configurations are automatically configured for you to make the path work. And same goes for Impala as well. So you say Impala is using Sentry service, and all the queries which go through Impala would now go through Sentry as well. So it's that simple. So once you have your cluster configured, so I'm going to show you simple examples on how an admin can grant and revoke privileges. And as Xuefu mentioned, on the Hive side, on the DB model side, we allow privileges at server level. So an admin can have all the privileges read, write on server level, which means an admin can create new databases, dump data into data tables, and so on. And then you can also have users have access on database level. So you can have maybe a sensitive database which only a certain set of people are allowed to access. So you can have a database level. And then you can also have access at table level and view level. So even with the table and view level, you can have either select access, insert access, or all. So usually select access gives you permissions to read the data. Insert access gives you a privilege to dump data into the table. And all basically gives you privileges to alter the data or metadata. So let's go ahead and give some privileges to users. By the way, this is a Kerberos cluster. So the way Hive Server 2 authenticates a user is using the Kerberos cache, credential cache. So I'm going to create an admin user. So basically pre-created some roles here. So there's a DB1 all role, admin role, and a DB1 select role. So we can see what these roles actually have privileges to do. So the admin role, as you can see, has all privileges on all the databases. So that's what we want. We want an admin user who can do essentially, read, write everything. So as I'm logged in as an admin user, I should be able to, create a new database. So this user has been successfully able to create a new database. So the DB1, if you look at the DB1 all role, so there are two privileges. We can remove one of those. So it says I have all privileges on DB1. It also has all privileges on default, which we can go and revoke. Let's see how to revoke a privilege. So we revoked all on database default from role DB1 all because it doesn't make sense. So let's again, look at the grants we have. So as you can see, the backend database got refreshed and only DB1 privileges are there here in the role. So as you can imagine, if I now assign this role to a user, that user will only be, do any operations on that particular database, and he'll not be able to, see any tables or create any tables in any other database. So I'll go ahead and assign this role to a user, and let's see what happens if that user tries to create a table in another database. So as you can see, as an admin user, I'm able to see the tables in the default database. And same will not work if I log in as a user who doesn't have privileges. So as you can see, this user only has privileges on DB1. So if I do a show tables on the default database, all the tables will be filtered out. They'll not be visible to this user. And if this user tries to create a database, Sentry would throw an exception saying, you don't have enough privileges. And this user has all the privileges on database, so he was able to successfully create a table in the database. So it's very intuitive, and it's very similar to the SQL, traditional SQL world, how you grant and revoke privileges. So this is how you can set up a cluster with Sentry and get started and give the privileges. We'll be available here to take questions.
When both the services are on, Sentry as well as Hive, interacting with the meta store, what kind of a performance degradation you see when you configure a role-based security?
So Sentry, so Hive Metastore, so Hive Metastore and Hive Server 2 both talk to Sentry service, not the other way around. So in the case of Hive Metastore and Hive Server 2, there will be one call for each query. If you think in terms of how long, for what use cases we use Hive, that might not be very, visible. I wouldn't think it will take a lot of time. It depends on, availability of the Sentry service, of course. But in the Impala world, as we want real-time results, the privileges are cached, so it shouldn't take any time at all. It's all in memory.
There's one more question, that if my Sentry service is crashed, how it will impact the ability to do any kind of a query on Hive?
Very good question. So that's an important problem to solve. So right now there's no high availability in Sentry, but yeah, that's something we're working on.
Thank you.
Is Sentry in production, in a production environment?
Yes, there are some customers using in production.
Any comment on the row level security? So far it's on table level.
Table and view level right now. Row level, would be tricky. Do you wanna?
Yeah, I guess we are looking into it. The current solution is sort of to use it via views. So you add predicates in your query, and that sort of gives you some degree of row level security. But that's something we are currently looking into. But
Any time frame?
No, I mean it's a community-based project, so we really can't commit a time frame. But
I know,
it's,
but
I mean,
like sometime this year, next year.
No, I really don't know, but it's, I mean,
Yeah, that's okay.
we would really like to get it this year, but it doesn't, but yeah, I mean, the column level security and row level security are two things on our like sort of nearest roadmap, so yeah, I'll hope it's come out this year, but don't quote me on that.
I mean, it's a good thing that it's open source. If you want it comes faster, then you can help us.
Yeah, you can file a Jira and put sufficient pressure on that, and then you can.
Spark, Shark.
No, this is. Yeah. The question was, is there a plan to enable this for Shark? So I think nothing that I guess we are actively looking into, but not directly on Shark and Spark. But I guess again, the people from that community could very well contribute to this to enable it for Shark. But sorry.
Yeah, I think the most important things is in our short term. Of course, Sentry is an open source project, so anybody who wants a feature can contribute or request features. So a few things we've seen in the field is even today, if we want to allow big and MR users to access files in the Hive warehouse, it's not pretty straightforward because of HDFS permissions. So there's this HDFS permissions which you maintain using extended ACLs, and you have Sentry permissions. So you have to keep them in sync. So the short-term goal is to somehow make HDFS maybe talk to Sentry and have one source of truth and one source of one place where users can manage their permissions. Yeah. All right. Thank you.
Thank you.